part 1 of Unit 8, Circular Motion and Gravitation today. Today we're going to talk about centripetal acceleration, tangential velocity, and how to calculate those things. I know those are words that we haven't heard before, so let's just dive in and define them. So centripetal simply means center seeking, all right? It's not, you're going to want to use the word centrifugal, which looks like this. Centrifugal. And here's what I'm here to tell you. This is not a real thing. You need to remove it from your vocabulary immediately. I never want to hear you say it, all right? Centrifugal is not a thing. We are talking about centripetal acceleration, okay? Now, here's what I want you to imagine. I want you to imagine that you are sitting on a Ferris wheel, all right? You're on this Ferris wheel, and it's moving around in a circle, all right? Your velocity is not changing while you're on this Ferris wheel. You're moving at a constant rate, a nice slow rate as it goes around, all right? But what is changing is your direction, okay? You're not going in a straight line the entire time. You're moving in a circle. And the thing that is causing you to change direction is the centripetal acceleration, all right? Centripetal acceleration is acceleration that points towards the center of a circle. It is this arrow right here on our little diagram, pointing towards the center of the circle, all right? Now, tangential velocity is the velocity at a single point along this path, okay? So if you've heard tangential before, it's probably in a math sense where you have a tangent line, a line tangent to a point. All this means is that a tangential line touches at a single point, and for our purposes, it's perpendicular to the radius, okay? So you can see this at these locations right here. I have this line to represent my tangential velocity at each of these locations. And notice that this line touches only at a single point along that rotation, okay? So the key things that we need to remember: centripetal acceleration points towards the center of a circle, always. Tangential velocity is the velocity at a single point of that path, and it is perpendicular to the tangential acceleration, okay? So, moving on. Let's talk a little bit about acceleration, kind of a review here, all right? Acceleration at its core is a change in velocity. A change in velocity. Now, remember, velocity is a vector, and vectors have both magnitude and direction, okay? So if I change velocity, a change of velocity could be a change in its magnitude, so a change in the number, a change in the direction that it's going, or a change in both of those things, all right? We have primarily worked with simply a change in magnitude. So that could be you slowing your car down as it gets to a stop sign, all right? A change in direction could be you turning your car, all right? So you hit that stop sign and you turn your car to the right. You are changing your velocity because you're changing the direction that you're going, all right? Now I want you to imagine that you are approaching a turn and you don't slow down, okay? You go the same speed, but you still turn the car. Because you are changing the direction that you're going, you are changing your velocity, even though the value of your velocity didn't change. This right here is circular motion, okay? So that centripetal acceleration does not change the magnitude of the velocity. It simply changes the direction that you're going. All it's doing is changing the direction. It is not changing the magnitude, all right? Now we have a way of calculating this. We can calculate this by saying that the centripetal acceleration is equal to the tangential velocity squared divided by the radius of the circle, all right? Where AC represents centripetal acceleration. We measure acceleration in meters per second squared. VT is the tangential velocity in meters per second, and radius is represented by R in meters, all right? So the easiest way to do this, guys, is just to dive into some examples, all right? So let's say that we have a test car, and this test car is moving at a constant speed around a circular track, and let's say the car is 48.2 meters from the track center and has a centripetal acceleration of 8.05 meters per second squared. What is the car's tangential speed? All right, first thing we want to do, let's draw a picture, as always. All right, so here's my circular track, and let's say that my car is right here. All right, here's my car. Let's say that I'm viewing this from above, okay? So I'm looking down on the track, and I'm looking at the car. At this moment, the car is moving in this direction. This is the tangential speed. So here's what I want you to imagine. Let's imagine that the car stopped turning at this moment right there. If the car stopped turning at that moment right there, it would continue in that direction, all right? So at this moment, the radius of this car, so here's the center of the circle, the car is 48.2 meters from the center of that circle, all right? So let's define some variables here. The radius is 48.2 meters. The centripetal acceleration, AC, is 8.05 meters per second squared. And what we want to know is the tangential velocity, the speed at that point. So we start with our equation. Centripetal acceleration is equal to the tangential velocity squared divided by the radius. All right? Now, I need to know what this is right here. Okay? So first thing I want to do is I want to rearrange this equation. All right, so if I rearrange this equation, I'm going to multiply by the radius. So then I'm going to have centripetal acceleration multiplied by r equals tangential velocity squared. And then I'm going to take the square root. All right, so what I get is that the square root of the centripetal acceleration multiplied by the radius is equal to the tangential velocity. Now all I need to do is plug in. So this becomes 8.05 meters per second squared multiplied by 48.2 meters, square root of all that, is equal to the tangential velocity. And when I solve this out, I get that the tangential velocity is equal to 19.7 meters per second. All right? So you could use that equation to solve for acceleration. You could use it to solve for radius, whatever you'd like. But what we need to remember with this, and what's tough, is that centripetal means center seeking. It always points towards the center. The centripetal acceleration changes the direction of the velocity, but the velocity magnitude stays constant. So the total velocity, the speed of it, the magnitude of that velocity stays the same, but the direction is changing because of a centripetal acceleration. All right, these are some weird concepts. I'm going to have some practice problems for you guys today, and we'll just keep diving in on this stuff. All right, have a good day, everybody.